multi-stage problems. Some questions will ask you to find a missing quantity, and then go on to use this to find another one, possibly using Pythagoras theorem and trigonometry. In question 1, we have a quadrilateral composed of two right-angled triangles, ABD and BDC. And the given information here is 16 centimeters, 12 centimeters, 40 degrees, and two right angles. And what is wanted? The length of CD is wanted. And the side CD belongs to the triangle BDC. And when I look at this triangle, it is the information here is only an angle and not enough to find the value of this side length CD. Then I need one more side length, so it is going to be helpful if I can find the value of the side length BD. To find this value, I go to the other right angle triangle, and I'm going to use, because I know two side lengths here, I'm going to use Pythagoras theorem to get the side length BD. Here the hypotenuse is 16 centimeters, so 16 square, I'm using Pythagoras, so 16 square equals 12 square plus BD square. Now leave BD alone, so 16 square minus 12 square equals BD square, and take the square root of this calculation and use your calculator to get the value. So BD is 4 square root 7. I use the exact value for BD. I advise you not to round off too early, because we are going to use this value into another calculation to reach the answer. So you should use the full calculator value or exact values of any previous calculations. Otherwise, inaccuracies can affect your answer, so that your work may be far away from the real value. Therefore, I use the exact value of BD as 4 square root 7. Then look at the other triangle BDC. Now I know an angle and I know the opposite side of it. According to the place of 40 degrees, it is the BD is the opposite of 40 degrees, and the wanted side CD is the hypotenuse of that right angle triangle. And opposite and hypotenuse, that's right, SOHCAHTOA. Opposite and hypotenuse is here, so sine will work in this question. Sine 40, always take angle next to the sine, cosine or tangent. So sine 40 equals opposite over hypotenuse, which is BD over CD. And I know the value of BD, which is 4 square root 7. So sine 40 equals 4 square root 7 over CD. Try to leave CD alone. That goes this way. Then I will take sine 40 by dividing. So CD equals 4 square root 7 over sine 40. And your calculator will give you the answer. According to the three significant figures, this is 16.5 centimeters. Let's continue with the second question. There is a triangle which is composed of two right-angled triangles. A big triangle is ABC. One of the right-angled triangle is ABD, and the other one is BDC. What are the information given in the question? The side AB, which is 7 centimeters. The side length BC, which is 12 centimeters. There are right angles here. And the angle A, which is 65 65 degrees. And what is wanted? The length of AC is wanted. AC, the side AC belongs to the big triangle. If I can find the length of AD and the length of DC, then I can add them to get the wanted length of AC in the question. So how to do that? First of all, let's start with the triangle ABD. I need the length AD and I can find it. AD is the adjacent side of 65 degrees and 7 is the hypotenuse of the triangle. So adjacent and hypotenuse is used in cosine. So I will use cosine 65 equals adjacent over hypotenuse. Adjacent is AD over 7. And 7, I try to leave AD alone. So 7 goes this way. You have 7 times cosine 65. And AD is on your calculator display. And don't round anything, just copy what you see on your calculator. 3, 2, 7, 8, 3, 2. This is the value of AD. Okay, I can check how am I going to find the length of DC. And DC belongs to the triangle BDC. And there isn't enough information to get that value. We only know the side 12. That's why I need one more side, and BD is the common side for both of the triangles. That's why I'm going to get the value of BD from the triangle ABD. So again, I'm going to use the trigonometry. And you can also find it by Pythagoras theorem, because now you have the values of two sides, and this is going to be the third one. But our topic is trigonometry. That's why I choose to find it by using trigonometry. So BD to be found is the opposite side of 65. So opposite and hypotenuse can be used in sine. So I choose sine 65 equals BD over 7, opposite over hypotenuse. Same style as I did here. So 7 goes this way. So 7 times sine 65 will be my value of BD. And it is 6.3444154509. Then from BDC, triangle BDC, I can find the length of DC. And before doing this, I want to change my pen's color. Okay, so because I know BD, the length of BD, and I know hypotenuse, I am going to use the Pythagoras theorem in this triangle BDC to get the length of DC. So 12 is the hypotenuse. That's why I'm going to leave 12 on one side. 12 square equals BD square plus DC square. So I want to reach the value of DC, so I would like to leave DC alone, move BD to the other side. Because it's a long number, I prefer to write BD instead of that long number in each step. I will use it at the end. Then I take the square root of this. Okay, so instead of copying this long number in the place of BD on your calculator display, you can press ans button. And ans button, you have ans button in your calculator, because the value of BD is the final answer and it keeps this value on the memory. That's why ans button keeps this number. Then whenever you write what you see, the square root sign underneath, you write 12 square minus ans on top square. So let me write it. Square root sign 12 square minus ans square, and go outside, move with the arrow button to move outside of the square root and press equal sign, and you will have the value of DC on your display. This is another long number, 10.1858 again 5802. So we are one step away from our answer, our final answer. So our final answer must be the length of AC. AC is the total of AD and DC. Now your calculator has DC, so keep it on your display. Don't press anything yet. So because you have this, press plus, then go and copy the number, the value that you found for AD, 2.958327832. You're going to press each button to write it on your display, and press equal sign to get another long number for AC. You will see the long numbers and do approximation as wanted in the question. So whenever you do approximation correct to 3 significant figures, you will have 13.1 as a final answer.